Okay, so today we're looking at how to graph the derivative. I know this is an unfamiliar term to you, but derivative, remember from last chapter, means slope. And what's more, another way that they can express derivative is by using this. It's what they say as f prime. If you see that f with an apostrophe, in mathematics, that means f prime. So if you want to sound mathematically intelligent, you're going to say f prime or derivative. That's what that means. And again, derivative means slope. So this is basically saying, I want you to graph the slope. You might think, graph the slope? Yes, exactly. What we want to know is basically what's happening on this graph. If I was to ask you to take a little trip with me, and this was our trip, this graph that you have in front of you would be our trip. Let's just say we're starting here at the x. And so what I'm doing is we're taking a trip. And we would be like, okay, we're traveling. And here at this spot, what is happening? Think to yourself, what would that mean if this is me in a car? This means as time is going on, we get to this spot, and then what's going to happen? We turn back, and it's almost like, oh, we've missed our turn, and we go back. And so then we catch our turn, and we get off at the correct exit, and then we start, oh, now we're going to proceed forward again. So this represents almost like going back. And then we would increase again, and then, oh, we got there, and if we wanted to hang out there for a while, you might see like a flat spot, and then a decrease, meaning, okay, we stayed, and then we returned back home. That's, in essence, what's happening here. That's what this graph is all about. And that's what graphing the slope is doing. Eventually, in calculus, we'll look at what these graphs of slopes mean and how these can help us in terms of other interpretations. In particular, we'll talk about velocity and acceleration. I know for all of you physics students, that's exactly ringing your chime right now. But that's what that's about. And in fact, we can talk about maximum and minimums. And again, those are buzzwords that you'll hear a ton in calculus. So all of this actually does bear meaning. I know right now it kind of seems like, what in the world are we doing? But the truth is, for right now, we're just trying to get a handle on what slope is, okay? So when we're looking at a graph, if I need to graph its slope, the first step in graphing slope, the very first step, is actually, I'm going to move this guy out of the way. The very first thing that we're going to do is we're going to look for where the maximums and the mins are. Where the maximum and minimums are, this is when your slope is 0. I want you to think about that. We've talked about that a number of times. That if I was to ask you the slope at this spot, and the slope of that tangent line would be a horizontal line. Similarly, you would see that here at this spot, and at this spot. I could pick any of those. The slope at any of those maximums or minimums would be 0. So if I'm to graph the slope, the first thing I do is recognize, okay, the slope here is 0. And so therefore, on the graph, right below it, I'm going to mark my graph of the slope is going to cross at that spot. And similar, this spot right here, where we're also recognizing as a minimum and the slope being 0, I would have a point that would basically be at 0 on that spot. And again, lastly, at this maximum spot, it would be right below. So the first thing you do is you mark the maximums and minimums. Step number 2. This is reminding you that when you read, here in America anyway, you read left to right. So we're going to look at the graph. Okay? And you're going to determine if it's increasing or decreasing. Now, these graphs will get much more sophisticated in calculus, but for right now, this is all I'm asking for. What I want you to look at here is, what is this graph doing leading up to that spot? See, if this is me traveling, I am increasing. All the slopes along this would be considered positive. They all would be positive along this line. And so that would mean that all of the values to the left of this dot, on the left-hand side of this dot, would be positive, all of those slopes. And technically what's happening is it's very steep, and it starts to slow down. If this is me driving, this is when my foot's on the gas, and then as I move, it increases, okay? And then I'm slowing down. And then I come to a stop or turn around, and then it changes the direction. So you'll notice the same thing. So all I want you to do is recognize these are all positive. And so you just draw a line off from that above the x-axis. Increasing slope means that your graph is above the x-axis. Okay? Now, if it's decreasing, as you see here, between this point and this point here, it's going down. It's decreasing. In fact, it starts kind of slow, then it speeds up, and then it slows down again. Again, starts slow, speeds up, whoa, and then slows down. It's kind of like when you're skiing down a hill. You start a little slow, then all of a sudden you pick up speed as you're going down that hill, and then immediately, as you hit the bottom, it starts to slow down. So decreasing, again, what are these slopes? These slopes are all going to be negative slopes. And so we would graph f prime below. And truth be told, it's as simple as this. You have two dots here, and you're going to graph below. You're just going to connect the two dots with a bump. Now, I'm not going to be specific as to how low that bump goes. Again, that's calculus that we get to that. So I'm not going to stress about that for you guys. All you have to know is it's below. And then what's happening between the next two, the minimum and the maximum again? This is increasing. Again, it starts slow, then it speeds up, and that should be indicated. Starts slow, then it speeds up, and then it gets back to slow again. And then lastly, it's decreasing. These are all negative slopes, and so you can make sense out of that. And so the graph of f prime here is this one here in purple, although my original is kind of looking purpley right now, but it is this major graph here that you see. All right, another example. Let's try another one. And we've got a whole number of examples, and I really want to kind of focus on those as well. There's some other things to consider, okay? Some other things to consider is that when you have jagged edges or you have odd shapes or what that looks like, and we'll get to that in a second. Before I do, though, I actually want to work on this one here at the bottom. So I'm going to do this one away from all the other writing, and then I'll come back to those other two where they have odd shapes. So once again, first thing you want to know is what? Minimums and maximums, correct. Here's the minimum maximum. What's that mean at that minimum or maximum? In this case, it's a minimum. So what would that mean? I hope to hear that you're saying slope is 0 at that spot. And so that means that on the graph, that what I would do is have a point at 0 on that. Okay, so good, excellent. Now what we want to do is we want to kind of get a handle on what's happening to the left and to the right of this. To the left, as we move from the left to the right, it's almost 0 here. Do you follow that? And then it's doing what? It's decreasing. And it picks up speed, and then it slows down again. So it's 0 almost. Then it would increase slightly, and then it gets more extreme, and then it slows down again. So watch how I'm going to graph this. It's a little tricky here, but it would be like almost 0, and then as it picks up, and then we'd come back in at 0. I know that's tricky, but understand this is, if I was to put values of slope here, at this spot here, we would have a pretty high slope. It would be an increase, maybe 2, maybe 5. And then in here, though, it might be a half. And as you slow down again, it's back to that 1/2. And so you'll see that that kind of shows up on that graph. In a similar way, now what's happening at this side? To the right of that minimum, now we're starting to increase. Again, it starts slow. It increases, and then, it slows down substantially. And so you can see how that graph looks. Okay, so step 2 again is to note the increasing and the decreasing. Good. All right, let's do some of these trickier ones. All right, so now what happens when I have a point like you see here? Well, at this point, where these two, what appears to be lines meet, there is actually no slope there. There's no slope. It's a hole in the process. It's an actual hole in the derivative or the slope. It doesn't actually have any slope value. So that's not 0, that's not positive, that's not negative. It actually is undefined. There is no slope there. So what does that mean? Well, let me just point this out. This is a line, yes? And we know that the slope of the line, no matter where we are on that line, is the same. It is the same. So when I look at this, I recognize, like if I said that the slope at this first spot is 2, then the slope at this spot is 2, the slope at this spot is 2. So how would I graph then that f prime? The way I would graph that is, let's say this is where 2 is. Then this would be 2, and to the left, it would all have the value of 2, all positive 2. At this 0 spot, though, it would be an open hole right there. In the same way, look at this to the right. These are all negative slopes. And again, if we said these were negative 2, then every one of these would be negative 2 along the way. And so I'd do, okay, here's where negative 2 is. I'd have an open circle, and everything to the right is following that value. But again, notice the open circle, since there is no slope there. All right, let's do another one. Last one. I'm going to erase this just because there's so much writing on here. It gets confusing. So now let's focus on this one. This next one, all right, let's just look at it. Do we have any maximums or minimums? Hopefully we recognize that one, right? That's a maximum right there. And so I would definitely point that out. That's definitely going to be a point below here at 0. I know that this graph is going to cross there, and that will be its own little issue. And we also should notice that there's going to be a hole here, because that's also there. All right, so what is the slope along here? Honestly, it doesn't matter what number you deem it to be. I would just say it's a positive number. So what I would do then is on your graph, when you're graphing your slope, I know that it's going to be positive. So I'm just going to do a line, and I don't even have to indicate what I think it is. I'm just going to literally have a straight line. It's all the same number all along that, and there it is. How about along this? What slope along here? Excellent, 0. Every spot there is 0. But again, we still have that hole that's going on. And do you see that jagged edge again? Well, there's another hole. That's what we're doing there. We've got another hole going on right there. Now, what's happening between this hole and this maximum? It's increasing, right? Starts crazy here. So what's going to happen is it's just connect between those two. It's increasing. It's positive all along there. From here, in other words, from this maximum to the rest of the graph, you're going to notice that it is decreasing. So it is negative. This will be below. And just notice the pattern. It starts slow, increases, goes a little crazy, and then slows down again, doesn't it? Almost to the point that it's a minimum. So increases, or it is decreasing, but it's increasing the amount of slope, and then it's going to slow down again, get very close to 0, but not actually there. And that would be the graph of those derivatives. And that's how you do those.